Okay, this is week 3 of CST370, and this is actually the second video for this week. And the first video give you an overview of the key topics for this week. And this video is going to focus on the overview of the lab and programming assignment, including the C++ programs provided to you. And so in case you haven't started or you have a difficulty of starting the assignment, and hopefully this video is going to help you on that. But by this time, at least I think most of you, if not all of you, should have completed assignment for module 2 out of week 2 assignment. Okay. So first of all, let me start with the set of a program provided to you, because that is the basis of the lab assignment as well as the programming assignment. So there is one lab assignment and one programming assignment, and both of them will be built on the set of C++ program provided to you. Okay, so the first thing you do is I would just install all these 3 programs. It's a QData structure program, and install them into whatever IDE you're using. In this case, I'm using Xcode, so I created project and imported all the 3 files. Very similar to the stack and the linked list data structure. These 3 files are for the Q data structure covered in this week. Okay, the header file, q.h, is the declaration for this Q class, including the data structure as well as the set of basic operations associated with this data structure, and all of them are defined within the class Q. Okay. Now the key operation of this Q, of course, is in Q, and just move an element into this Q, just similar to the push operation for a stack. You push in an element into the top of stack. And the DQ is an operation that remove an element from the queue, kind of similar to the operation of a pop, and from for the stack data structure, you pop an element from the stack. Okay. So first thing you may notice that at the bottom of this declaration, there is an array called a my array with the maximum length of the queue. It's called a queue capacity. And this indicates that we're implementing this queue data structure with an array. Now, from the videos and the materials you have gone through so far, hopefully, and there are 2 implementation methods. One is to use array, and the other one is to use linked list. There are pros and cons of each approach. And in this particular source code, and it is implementing the Q data structure using array. And the other one is, of course, you need to define the type of elements in this Q. And we can see that this declaration indicates that each element of the Q is of integer type. Okay. And if you want it to be of a different type, then you should change it here to a different type, like characters or strings or whatever type of elements you wanted. Okay. Now let's take a look at just one method. Okay, this is in Q. It's basically move an element with a particular value called value, and the type of that value is called Q element, and move that element into this queue. Okay. So the other thing you may notice that this array, which is really where this queue data are stored, is declared under this private, which means that this queue data structure can only be accessed with one of these methods associated with the queue class. Okay, you cannot manipulate the data structures, this array of the queue through any other means. So this is the basics of the OOP. Now, the other program, Q.cpc, is the implementation of these different methods, really. Okay, very similar to the stack and the linked list data structure. So, for example, for the in-queue method, okay, by now you should be familiar with this notation. This is a C++ notation with double colon. It indicates that this is a method belonging to the class Q. And the method is called in-queue. And the element or the parameters passed to this method is a value with the type Q element. Okay, so basically, you are going to move an element with this particular value into this queue. Okay, so the way it implements this is because it's an array-based implementation, and you will just need to check to see if this array is full or not. If it's not, then it's very easy. You just move the value into the array element and increase the number of the array, number of the elements in the queue by 1. Okay, so that's basically it. And the other one is the test program. And you just create any kind of test cases you like. And then let's compile this one. And the test program basically starts asking you, say, how many elements you want to push into this test queue. Let's say we want 5, and then it created a queue with 5 elements, and the first element is 100, and the second element is 200, and so on. So, and then it does a bunch of testing, like is this queue is empty? Of course it's not. And the first element in the queue is 100. That's the first one that you put into this queue, and then you remove one from the top of the queue, and then what's the remaining in the queue? These are just various test cases on that. Okay, so that's essentially the highlight of the program provided to you. So now let's go to the assignment. And the first assignment is called a lab, okay? And there is only one lab here. This lab, of course, will be built on these 3 programs provided, but you need to do a little bit of things. And this program asks you to read a text file, okay? And from that text file, there are some special notation. This is the braces. Anything that's within this braces is considered a footnote. And you can even create this sample files and to be ready into that. Okay. So let's take a look at and see what is required for this one. So this text you put into a sample file called a sample.text is, okay, this is the set of string. This part is the beginning, and this part is the footnote. This, this string is included within the parentheses, okay? So your program will read this sample input file, and the output should be like, this one you just print it out. Okay, this part is the beginning, and then also you print out the other one, say this part is the end. And for the footnote, you should recognize that this is the footnote. The way, at least one way, that you show your program recognize this is the footnote is just to print it out a separate one and say, this is a footnote. I recognize this is a footnote. And the footnote is this part is the footnote. Okay. So that's basically what is required for this program. And there are a couple of things to note about this one. Of course, the first thing is to outline the steps or the algorithm to implement this. Okay. And so the very first thing, you need to be able to recognize this footnote in the input string. So this is the input string. When you read that from that file, and you basically need to scan this input string one character at a time. Okay, and when you hit this character, it's the beginning of the footnote. When you hit that character, that's the end of the footnote. So you should be able to recognize, and then you should be able to extract the string from as the footnote. Okay. And one thing to note here is that the sample text, it says, okay, this is the beginning, this part is the beginning, this part is the footnote, this part is the end. It's one line, but your program should be able to handle an input file with multiple lines, and there could be multiple footnote, multiple substring with multiple footnotes. Okay. So once you recognize that such footnote strings, then you need to push them into a queue. Okay, the queue can have multiple elements, and each element points to a string. If there is only one footnote, then you have one element in the queue. If you have multiple footnotes, then you have multiple elements in your queue. Okay, and then after that, you just print out all the string that belong to the footnote. So one suggestion is, in addition to this sample test, which only contains one footnote on one line, maybe you want to also test your program with multiple lines and multiple footnotes to make sure it can handle that situation as well. The other thing you need to, I want you to note about is the element type. Okay, so in the example file, we show that the element type is integer. Okay, so an integer number. Now here, the element type may be different. So if it's a different element type, you may need to go back to q.h and q.cpp files to make corresponding changes over there. If you change the element type to be string, for example, then you need to make sure that those places that are specific to the integer element type should be changed to this new element type string. And another note is that for reading the content from a file, C++ has a class called if string, and you may want to check either the textbook or the online reference materials on how to use it and what is the proper way of reading the content from the file. All right, so these are the key things for the lab assignment, and the next one is for the programming assignment. Let's go there. So the programming assignment is ask you to write a program that reads a string of characters and pushing into a stack and as well as into a queue. So here you're going to utilize not just the queue data structure, but the stack data structure as well. Now, the purpose of this is to look at a string and see if the string is called palindrome. A palindrome is a type of string that the same from the beginning as well as from the end. For example, this string Anna, if you read from the beginning to the end, and then if you read from the end to the beginning, the results are the same. That's the colors. Okay. So basically, that's what you're asked to do. You are going to ask a user to input a string, and then you're going to determine whether this string is a palindrome or not. Simple as that. Now, this assignment is made much simpler because we told you what data structure to use. We asked you to use the stack data structure as well as the queue data structure. Okay, they have different characteristics. Okay, so let's go through an example and see how these two data structure may be utilized. And by doing several examples, you may derive an algorithm, and subsequently you can implement it in some programming language like C++. So one example here is that, okay, I have an input string, can, K-A-N, K-A-M, okay? And so the first thing I'm going to push each character of this string into a stack. So K will be at the bottom, A next to A, N is next, and so on. So N is at the top of the stack. Now, at the same time, I move this string into a queue data structure. So the first element in the queue is K, A, N, K, A, N, okay? So for the stack data structure, I can access the top. For the queue data structure, I can access the first element you move into the queue. So the top of the stack is here on the right-hand side. Basically, it's the end of the string. The first element of the queue is on the left-hand side. Basically, this is really the first character of the string, right? So now I can compare, if I want to determine whether this particular string is a palindrome or not, and I need to compare the beginning of the string and the end of the string to see each character whether they're the same or not. Since I have access to the end of the character of this string as well as the beginning of the string, then I can compare them. Okay. So of course, in this particular example, they're not the same, so it's not a palindrome. So let's look at another example. Suppose a user input A, B, and NBA, and you push this string into stack. So the stack looks like this. From the bottom to the top is A, B, and NBA, and the top of the stack is a character A. And at the same time, you move this string into a queue. So the queue will have A, B, and NBA as well. The first element of the queue is A, which is what you can get from the queue data structure. And then you get the character from the top of the stack, and also get another one from the first of a queue, and then compare them. And in this case, they are the same. Of course, just two of them the same doesn't mean the whole string is a palindrome, so you need to do more work and check. But this hopefully give you some idea how this may work and what how you can utilize the stack as well as the queue data structure for this assignment. Okay, once again, enjoy the rest of the week. Thank you very much.